Eric Archer here from Texas Instruments, and today we're going to go on a tour of the solar system. And our host on this tour is going to be the Hip Hop M.D. Hip Hop M.D., are you ready to take us on the tour?
I am absolutely ready to take us on a tour. And obviously it's going to be a virtual tour. We don't have the ability to go into space for multiple reasons right now, but we are going to tour space from the comfort and safety of our home. And so I'm really excited to take you on this brief tour. This will give you a better understanding about not only Earth, but how Earth interacts with our solar system and how we came to exist within our solar system. Because I think having a better understanding of what is around us gives us an overall better understanding of how we interact with our Earth and how we're able to navigate with our Earth. So I'm going to dive into my very first slide here as I share my screen with you guys. And this will give us a good understanding about Earth and our place into the solar system. Awesome. So we're looking at this vast solar system, and this is a great picture right here because you're able to see all of the planets that exist in our solar system, right? We have our first planets that are now what we consider our rocky planets, from all the way from Mercury all the way to Mars. And then we pass through our asteroid belt and we get to the gaseous planets, all the way from Jupiter all the way to Neptune, okay? And we see this picture and we think that things are relatively close. It's like, okay, I see where Earth is. I see where Mars, I see the size of Jupiter. Jupiter is really, really big. Saturn is really, really, really big. But do we really truly understand the concept of how vast space truly is? And it's something that's really, really tough to understand, right? When we see these pictures. So imagine yourself, you're driving your car, you're on a road trip with your parents or a loved one, and you're driving in the car, and right as you're driving the car 60, 70 miles an hour, you see things that are really close to you on the side of the road, whipping past you, right? Because you're going really, really, really fast, and things are really close to you. So as you're moving, things that are stationary just whip past you, right? Because of the speed that we're going. But larger things like the moon, right? If you're driving, you don't see the moon whipping past you. And that's because of the distance the moon is away. So I'm gonna do a little physical example just to kind of explain just how vast space is. So here we have Earth, right? It's not blue, see, it looks a little bit, this is a grape, obviously. But let's picture this as Earth, right? You see a grape, we've all eaten grapes, you all know the size of a grape. Just kind of give perspective, I don't have the fruit with me, but if Earth was the size of a grape, what do you think Jupiter would be the size of? Do you know, Eric? If Earth is a grape, how big would Jupiter be?
That's a good question. I know that Jupiter is much, much larger than Earth. So if Earth is a grape, my guess would be maybe Jupiter's an apple or an orange.
Close. Well, actually, not really close. That's a pretty good guess. And you would think so, right? An orange is maybe about this big compared to a grape. If Earth was the size of a grape, Jupiter would actually be the size of a watermelon.
Oh my goodness.
Watermelon. That's how big Jupiter is compared to Earth. It is huge. It is huge, right? And so that kind of just gives you a relative perspective. But let's talk about distance a little bit. So if Earth was the size of a grape, we have all these other planets that are around us, right? So if Earth was the size of a grape, the moon would be about 16 inches away from Earth, okay? So 16 inches, that puts us about here, okay? And obviously the moon is much smaller than Earth, but that'd be about 16 inches away. So now if we go a little bit farther, let's think about the sun. How far would the sun be away? If Earth was the size of a grape, the sun would be about 163 yards away. That's the size of 1.5 football fields. So if Earth was the size of a grape, the sun would be 1.5 football fields away. That's just how vast, just within our solar system, Earth is. And then Jupiter, that we talked about being the size of a watermelon, would actually be half a mile away, a whole half of a mile away from this little tiny grape that we see here. Jupiter would be half a mile away, which is absolutely amazing, okay? And then we talk about like other galaxies, right? We're in the Milky Way galaxy. Other galaxies like the Andromeda galaxy will be 1 trillion miles away. That just shows how vast space is. We talk about these numbers, right? These numbers start getting crazy. We talk about millions and billions and trillions, right? How exactly do we measure space? There are very unique things that we use to measure space. The first one that we use is called an AU, which is called an astronomical unit. Do you know how we measure an astronomical unit, Eric?
Is it something to do with how far light travels in some amount of time?
That would be another element that we use to measure space, which we'll get to after this one. An astronomical unit is actually the distance from Earth to the sun. which is about 93 million miles away. It's 92.5 million miles away, right? That's the distance from the Earth to the sun. We have now used that to be able to determine an astronomical unit, right? And so instead of saying, oh, trillions of miles or billions and billions of miles away, we just now use that measurement now to define things that are farther away from us. So Neptune, the farthest planet in our solar system, is what we call 30 AUs away. So rather than saying trillions and trillions of miles and kilometers, we now just have an astronomical unit, which makes it simpler to be able to understand and to be able to give a simpler number. So Neptune in relation to us from the Earth is 30 times farther than we are from the sun. So that's what we call an astronomical unit. But you brought up another unit that we also use to measure distances in space. And the one that you said was a light year, right? A light year is what we use to measure how far light travels in 1 year. So we all know light, we all know the speed of light, right? So we use the speed of light, how far light travels in 1 year to determine a light year. So now when things are super, super far away, we now move from astronomical units into light years, okay? And then the number one after that is what we call a parsec, which is measured by I believe it's 3.26 light years is a parsec. So once things started getting even farther and farther from there, we use AUs, we use light years, and we use parsecs. But there's a fun experiment that I always like to tell people and how we figure out distances, right? So we use distances by something that we call a parallax. So if you hold up your thumb, right, directly in front of you, and you close one eye, and you just see your thumb, and then you close your opposite eye, you'll realize that your thumb actually moves, right? It seems to move into different directions. And we always wonder why exactly that is. That's the phenomenon that we know of as a parallax. And so this is actually what we do to measure distances in space. So this same theory that we use when we close our eyes and measure the parallax, we use that when we're talking about astronomical numbers. So scientists will do something which is really cool, and they'll go to when the Earth is on one side of the sun, we will measure a distance to an object that's far away, and then we wait 6 months for the Earth to orbit and get to the opposite side of the sun, and we measure that distance again. So we're doing exactly what we do with our eyes, closing each opposite eye, and we take different measurements. And then we are able now to be able to calculate the distance using basic trigonometry that we use with triangles to be able to now measure a distance to see how something is far away. So that's how we come up with these different astronomical units, light years, parsecs, and AUs in order to be able to describe truly just how vast space is, which I think is really, really cool.
That is incredible. Yeah, that's wild. Just thinking about how far away things are from one another. And, you know, like you mentioned earlier, driving 60 or 70 miles an hour in a car seems kind of fast, but it would take a really, really long time to get from here to the moon or from here to the sun driving at that speed. We've got to go much, much faster to do those things.
Yes, absolutely, absolutely. And it's just mind-blowing just to think about how tiny and how insignificant we are just as humans here on Earth. The Earth is big enough as it is, just how our position in space is just so vastly insignificant. You know, just how big and vast space is. So it's always something cool and surprising that just baffles my mind every single time I think about it. All right, so we have 8 planets orbiting this huge, large plasma gas, which we call our sun. Which is actually a huge main sequence star. And so I think the really cool thing that we understand here is there's a unique interaction that not only we have as Earth with our sun, but all the other planets that exist within our solar system. Obviously, we have Mercury and we have Venus, which are the first planets before us, and then Mars shortly after us. But this picture here shows a nice scale of what our planets and sizes actually look like. If you notice us here, Earth as the third planet from the sun, the third rock from the sun, as some would say. This puts us in a very, very unique space compared to the other planets. But the really important thing to know is that space is vast. The distance between these planets is actually immense. And so the first one that we're going to talk about, if we're going to go into order here, we're going to start off with our amazing sun. So we're going to dive into your next slide. Boom. So I'm going too fast here, too sensitive. Sorry, guys. So here we have our sun, which is the center of our solar system. It's pretty amazing because at one time, prehistoric times, we actually thought the universe revolved around Earth, which made sense at that time because we didn't know that other planets existed and we didn't know exactly our place within our solar system. But we know now that within our solar system that the sun is the center. So this main sequence star is boiling at 27 million degrees Fahrenheit at its core, 109 times larger than Earth, which is really amazing to think about, right? When we always see the sun from such a distance when we're looking at sunsets and sunrises, but the immensity of our sun is it's intense. And so that's going to really come into play a little bit later on when we talk about gravity and how our Earth interacts with the sun. So our sun is a main sequence star, as I stated, mainly composed of hydrogen and helium. Within this core of our sun, we have so many different elements combining. It's so many elements going on. So we have nuclear fission, nuclear fusion taking place. And that destruction and combination of atomic particles and energy being released is what creates our sun and gives our sun this amazing heat. And we really think our sun is special, right? It is special to us, but our sun is really one of billions of stars in the universe. So we now have a better understanding through NASA and other space technology that we have and intense telescopes. We're able to see far, far away into the universe. And we know now that our sun is one of billions across the universe and varying sizes. Our sun is actually pretty small compared to a lot of stars that we have in our universe as well, too. So we'll go from the sun into our next planet that we have here, or to our first planet actually, that's closest to the sun. And that planet is Mercury. Here we go. All right, Mercury. So Mercury is really, really, really unique in a lot of ways. So this planet is what the first thing that makes the planet unique is that it's tidally locked with our sun. And when we talk about tidally, what exactly does that mean? We'll go into a little bit later about the moon and tides, but particularly with Mercury, it's tidally locked with our sun. It's so close to our sun that it has a similar orbit with our sun, which makes it very, very special. So as the sun continues to rotate, Mercury also rotates with the sun. And so if you think about the orbit within our Earth, right, it takes 24 hours to make one full rotation, and obviously 365 days to make a rotation around the sun. With Mercury, the sun and itself are tidally locked. So they're moving together almost exactly in unison. And there's no atmosphere in Mercury. Compared to us, we have our wonderful atmosphere that controls a lot of different things. But in Mercury, there's no atmosphere, which really involves its variances in temperature. So it can range from anywhere from negative 280 degrees to up to 800 degrees Fahrenheit, which is a huge range, obviously making this planet uninhabitable. So we already know right now that there's no possibility of life just because of the intensity of heat on Mercury. And another interesting fact about Mercury is the second most dense planet. We'll touch into what is the first most dense planet in our universe, but it is the second most dense planet. And really compared to a lot of the other planets, the first four that we're going to talk about are what we call rocky planets. And so Mercury is the first rocky planet in our solar system. Next up, we have Venus. And Venus is very unique because this is actually the hottest planet in our solar system. And you would think Mercury would be the hottest planet because it's the first one closest to the sun. But we talked about Mercury not having an atmosphere. And this is going to come into play a lot later on when we talk about the Earth in depth. But Venus actually has an atmosphere, and the atmosphere is what actually controls the heat on every single planet that is in our solar system. And due to its intense atmosphere, this makes Venus the hottest planet with a temperature of up to 860 degrees Fahrenheit. Clearly not an environment that any human would want to thrive on. So we know as well that Venus has no possibility of life just because of the intense heat. And we talk about clockwise retrograde rotation. So we know how the Earth orbits. The Earth moves in an orbit 24 hours a day. We talked about Mercury's orbit. The unique thing about Venus is that it doesn't move in the same counterclockwise rotation that Earth and the majority of our other planets move. It actually moves in a clockwise rotation. And scientists have predicted that it does this because of a possible impact from another large object, such as an asteroid or another planet early on in its formation, which causes Venus to rotate in the completely opposite direction. And Venus is actually the closest planet to Earth. So our sister planets that we have next to us are Mars and Venus. And due to its actual elliptical orbits around the sun, that certain times Venus is actually much closer to us than Mars is, which makes it very, very unique. If you're in a great atmosphere, a great location where you're able to see the stars clearly, Venus is one of the brightest objects that you can see in our solar system. So it's one unique planet that we can see right here from Earth. Mars is the next planet closest to us. And obviously there's a lot of things going on, a lot of hot topics going on right now with Mars. We've been talking about exploring Mars a lot with more rovers. And we do have a rover launch that's going to be taking off here within the next week with our new rover Perseverance, which is going to do some unique studies on Mars, collecting some rock samples and doing some more examination for possibility of extraterrestrial life. And we've all heard about Mars and the possibility of life on Mars. But why do we consider the possibility of life on Mars? That's really because, one, it's also in the habitable zone close to Earth, and two, its atmosphere allows it to not be as hot as Venus or Mercury, in a more controlled atmosphere. So we know that there's a possibility of life just because of the ability for life to exist. And we think that at one point Mars actually contained life because there's evidence of ice caps, polar ice caps that exist on the planets. So we know that there's a possibility for life to have existed. And we all know about our moon. We have our moon here on Earth that we all know and love every single day. But the unique thing is Mars actually has two moons as well. The moons of Phobos and Deimos, which orbit around Mars and make it very, very unique. But one thing we actually do know from a lot of the rovers that we've had exploring Mars is that Mars has a very, very unique climate system. It has one of the largest dust storms in the whole solar system. And that actually makes things very complex. We've had certain rovers in the past that have explored Mars that we've had difficulty actually being able to complete our analysis on because of the fact that we've had dust storms. So we've had rovers such as Sojourner and Spirit and Opportunity and Curiosity that have taken samples and taken amazing pictures of the formations on Mars. So we know Mars is also a rocky planet, very similar to Earth. And I think that makes it very, very, very special. So we talk about our rocky planets. We already discussed Mercury, Venus, Earth, and then Mars. Those are our first 4 rocky planets. So after we leave Mars, we pass through our asteroid belt, which is very unique as well too, because that's the location of asteroids, which are remnants of possible planets and remnants from the original formation of our solar system. So once we cross through the asteroid belt, we enter another amazing planet, which is called Jupiter. Jupiter is a very, very unique planet because this one starts off our first wave of gas giants. So Jupiter is known as a gas giant, and all the planets that come after Jupiter are also gas giants. And we talked about the difference between gas giants and rocky planets, and that also comes with the close proximity to the sun. The gas giants have a far, far proximity compared to Earth, Mars, Mercury, and Venus. So they tend to have gaseous elements rather than actual solid rock formations. So Jupiter is the largest planet in our solar system, composed mostly of hydrogen and helium. Unique fact about Jupiter is that it's actually considered a failed star. I don't know, Eric, you're still with me there. There's been the dynamic of the possibility of 2 suns, which I've always thought was unique. If Jupiter was actually about 80 times its mass, it would actually be another sun. So there was a possibility at one point that we could have had 2 suns in our solar system, which would have made things very, very, very unique. And so Jupiter, actually another fun fact about Jupiter, we compare it to some of our other planets, it actually does have a small ring system. It's not as visible as the next planet that we're going to talk about, but it's a very, very faint ring system. And that's also due to its orbit as well too. So moving on from Jupiter, we have our next planet, which is Saturn. Now, Saturn has a very, very unique shape compared to other planets because it has a very, very quick rotation. So we talk about how Earth takes about 24 hours to make one full rotation, and it's much, much quicker for Saturn. And that's what actually causes its unique shape. If you take a look at how Saturn is shaped, it has more of an oblique egg-shaped, much, much wider around its equator. And that's because it's revolving and rotating so quickly. It has a very, very large, extensive ring system. So those are all small rocky objects that were all created at the formation of Saturn, which makes it very, very unique. So Saturn is unique in its shape, unique in its size, and unique in its amazing ring pattern. So moving on from Saturn, we have Uranus. Uranus is also a very unique planet because similar to Venus, it also has a rotational retrograde. So this rotates clockwise compared to other planets, especially like Earth that rotate counterclockwise. But in addition to rotating clockwise, it's also at a 98-degree axis. So unlike the other planets that, like Earth has about a 23.5 degree tilt, the other planets have a slight tilt as well. But Uranus actually has a full 98-degree tilt. So it's almost completely on its side. And that's possibly thought to be similar to Venus. At one point, another large rocky object or another planet perhaps made an impact with Uranus, changing its complete rotation. And it's also one of the coldest recorded temperatures of all the 8 planets in our solar system. After we pass Uranus, we get out to Neptune, the most distant planet in our solar system. And Neptune is very strong because, similar to Jupiter, it possesses very strong solar winds. It has a very, very unique climate system, and also possesses a very small ring system as well. We don't normally see it on pictures. When we look at pictures of Neptune, it has a very, very faint ring system around this planet as well. And so this kind of gives a brief overview of some of the other planets that exist in our solar system. So this gives us a great understanding about how Earth looks and the components of Earth and its correlation to all the other planets that exist in our solar system. So having a better understanding about what's around us and how all these other planets are made up will give us a better understanding exactly of what Earth is. And so I'm going to exit out of this share mode here, because the next slides and the next discussion that we go into will dive into a little bit more about Earth's core, how Earth is made up, the elements of Earth, water, land, the geography, and the atmosphere, and how all these different elements really comprise and shake up and make up what is Earth. So interested to go into that next topic session with you, Eric.
Yeah, Hip Hop M.D, that was great. Just seeing all of the different planets. I love the first slide you had where it sort of showed how all the planets are, the sizes relative to one another. And, Earth's not the biggest planet in the solar system. In fact, there are much bigger planets than Earth. And then I loved how you went over the sort of the 4 first rocky planets, and then the rest of them are gaseous planets and the differences between those. So, yeah, that was a fun tour of the solar system. I really enjoyed that.
Yeah.
Thank you so much.
Yes, absolutely. Absolutely. Someday we'll all have a chance to go on a great tour of our solar system when the technology comes together.
That's right. Yeah, that's right.